number 4 is the next one that I considered a bit more difficult. Though I really hope a lot of you guys got this question correct, because we really drilled this last week. So you should have read this question and gone half mass, half radius. Ooh, if I'm changing something, if I'm changing a mass, I'm changing a radius, we need to think in terms of proportionality. In order to think in terms of proportionality, you have to know what formula is being referenced. So because we're talking about weight is equal to the force of gravity acting on you. So this was the G m1 m2 divided by r squared formula. So because I want to know what is the weight, right? What does the weight equal? That means I need to have the weight by itself in order to do these proportionalities, and good to go. Weight is already by itself, so I don't need to reorder this formula. It's good to go. So I want to say how weight is proportional to mass and how weight is proportional to the radius. So take a second. I'm just going to give you a second to think about it. Look at the formula. How is weight proportional to mass, weight proportional to radius? We've done this a couple times with this formula. Well, the mass one should have been quick because mass is just in the top and it's just, there's nothing on it. Mass 1, there's no squares, no square roots. So however I change mass 1, I'm changing the weight the exact same way. But the radius has two things. The radius is not only in the denominator, but it also has a square on it. So I am taking half the mass. So what I have now is 1/2 the mass. So what I want to think is, based on this proportionality, what does that mean I now have for the weight? If I have half the mass and the weight is directly proportional, exactly proportional to mass, what does that mean I have for the weight now? Well, since they are exactly proportional to each other, that means however one gets changed, the other one gets changed the exact same way. So now I have, on this guy, I also have half the radius. So we need to be careful with this. I am plugging in half the radius where I saw r before. You have to be careful with this. So this is going to take a little finagling. So I've got 1 over, right? That doesn't change. Where I had a radius, now I have r over 2. So parentheses are your best friend, but it's r over 2 squared. So let's finagle this a bit more. This means I have 1 over, and then in the bottom I have r over 4. Now again, when you divide by a fraction, this is 1 divided by a fraction. When you divide by a fraction, you flip it and multiply. So what this really is 1 times, flip this fraction, 4 over r. Ooh, sorry. Ooh, I am a bad teacher. Squared. There's a square there because r gets squared and the 2 gets squared. So what I now have is then I have 4 over r squared. Now again, 1 over r squared gave me w. What does 4 over r squared give me? 1 over r squared gave me w is what this proportionality tells me. What does this tell me then when I have 4 over rw? That tells us that we have 4w. Again, 1 over r squared gave me w, so 4 over r squared, that's literally how we know what the number is. If the 4 was in the bottom, then we'd have 1/4 w. But the 4 is in the top, so we have 4w. Okay, so what we have to do then is we take these two numbers. This is what happens when I change the mass. This is what happens when I change the weight. And I multiply them together. So what I actually have is double the weight. So if we look up here, it's asking if somebody weighs 800, what would they weigh on this planet? Well, they'd weigh double their weight, and so they would weigh 1,600.